Welcome to the tutorial on radians, arcs, and sectors. Okay, so before we start, I just would like to refer you to the formula sheets that is given to you in the exam. First of all, you'll be given two formula, mainly for this particular context or topics. So first of all, S, which is the length of an arc, is equal to r theta, r times theta, the angle of the arc. And also the next equation is the area of a sector, which will be given to you as A equal to half r square theta. Now this is slightly different to what you get in GCSE maths. Okay, that is because both of this theta, the angle theta, is in radians. Okay, so it's not in degrees. So whatever, in a moment, what you're going to do is, if you're going to use the formula given in the formula sheets, unless you recall the formula of from the GCSE, then you could stick with the 30 degree. Otherwise, you've got to change the 30 degree into radians. Okay, so with question 1, so first of all, to change gradient into degree, you times, so let's give you another one first. So if you are going from radian into degrees, you go and divide by pi, and then times 180. Otherwise, if you're going from degree into radian, which is in this case we are going to have to divide by 180 and then divide by pi. And then you will get that. Okay, so since we have 30 degree, okay, so I'm going to have to divide by 180, and on here now I think it's times by pi, because it's always the opposite. So the revision guy had made a mistake, so it's not divide by pi, it's times. I'm sure that's the case. So then you have 30 over 180, and then cancel that out, which is 1/6, and then you go and times by pi, so therefore is pi over 6 is the is the angle in radian. So the questions want you to find the arc length, which is S. So S is equal to r times theta, and r is 4, times by pi over 6, so which is 4 pi over 6. So if you put it in the calculator, so I can never remember how I should do that. How do you change it into radians? I think it's the shift and then 2. Oh, so shift that number 2. So is there a choice here? 2 is ORG. Yeah. Nope. Oh, I see. So I think let's go here and 4. Okay, so now it's in radian mode. So I go 4 times pi over 6. And that will give me 2.09. So the arc length is 2 2.09 centimeter. Okay, so I'm just going to quickly check the back of the book. Yes, it is 2.09 centimeter. Indicate to the examiner that you are rounding it to 2 decimal place. Okay, so now on to question 2. So a plasma cutter is used to cut sectors of a circle for ventilation trunking. The arc length is given, so the S is given as 450 millimeter. The radius is given as 1 meter. Now notice millimeter, meter. Find the angle in radians of a sector, hence the number of complete sectors that can be obtained from a circle of sheet metal with radius 1 meters. Okay, so let's try this out. So I'm given S and R, so I can find angle, couldn't I? So S equal to R times theta, so theta is equal to S over R. Okay, so therefore S is 450 millimeter, so I usually times 10 to the power minus 3 over 1 meters, and then that will give me the angle theta. So put that in the calculator. Again, it working in radians. So 450. Oh no, we don't need the fraction. Sorry, because it's divided by 1. So 450 times 10 to the power minus 3. Let's try and use this more often. So it's 0.45, and that is in radian. Theta is in radian. So so that's the okay. So the number of complete sectors can be made with from a circle of sheet metal with radius 1 meters. So so that means how many 0.45? Radius is 1 meter now. Arc length and so let me think find the angle in radians of a sector, and hence the number of complete sectors that can be obtained from a sheet metal of radius 1 meter. Okay, alright, so that's simple, because you've got in a full circle, so in a full circle the complete angle is going to be 2 pi, because 2 times pi is usually, think about it, pi is 180, so 2 lots of 180 is 360. So in a full circle is 2 pi. So how many of this fit into 2 pi is to divide by 0.45. So I go ahead and do that, and so I go 2 pi, then divide by 0.45, and that will give me 13.96. And so therefore can't form 14 because it's not got enough, so it's going to be 13 complete sectors. Okay, so let's double check this again. Hopefully sounds about right, because is yeah, so that's the right answer. So 13 complete sectors. So yeah, that's it really. Okay,